If you haven't already, please pause the video and complete the 5-question warm-up. All right, for today's warm-up, there was some graphs that I wanted you to look at, and I wanted you to name them based on what you did yesterday, discuss their symmetry, and tell me what the max R value is. Now, obviously, at this point in your understanding, you're using Desmos. You don't know enough about these to know this with maybe just from memory. As you work with them more, you do start to memorize different things about them. For example, I know that when I'm dealing with limasones, both question 1 and 2 are limasones. But if the two numbers are the same, we classify these as cardioids. And you can see why when you look at the graph of these, they look more like a heart. They have this heart shape. So as a result, we call them cardioids. So think cardio, the heart. If the two numbers are different, though, we were just going to call them limasones. Depending on the relationship of these values, you may see what we call a convex limasone. You may see a dimpled limasone. The key idea is that you're getting something that's not quite a circle. So you'll see that it's shaped a little differently. It's more, you don't see that perfect symmetry like you do with circles, in the sense that there's like this radius that is the same for all parts from the center of it. So from there, you were asked to, discuss the symmetry. One thing I want to bring up is this idea of the symmetry with sine being that y-axis and with cosine being the x. But keep in mind that these can have more than one type of symmetry depending on the shape that we're looking at and how it is centered about the origin, or in this case, we call that the pole. Another thing that you might notice is that when dealing with limasones, if you add the 4 plus the 3 or the 3 plus the 3, that's going to tell you the maximum R value. Now, you may say, why is that the case? But just think about when we graph these by hand. Remember that when you are graphing, you start with the D value, and that tells you your midline. And then the A value tells you the distance up or down you go from that value. So if you think about a D value of 4, the highest up you're going to go from 4 is 3 units. So notice that maximum value would give you 7 when you add those two together. Same thing over here. If you have a midline at 3, well, if you add 3 units to that, that's going to give you that maximum value of 6. Now, with the lemniscates, you will see that when you take the square root of that number, that tells you how far out you go in any one direction. We call those that propeller length. With the roses, notice that this number right here in front tells you the length of the petal, which would give you that maximum R value. And then with circles, since this represents the diameter from this pole, from the center being at the pole, then obviously you're going to see that that's going to give you that maximum R value. So let me know if you have any questions on that. Again, I really just wanted you to use Desmos to kind of see that, and hopefully you're starting to see some of these patterns. For today's notes, I'm actually going to have you guys use your graphing calculator. Now, you may like Desmos, and Desmos may be more user-friendly, but it is important to know how to use your calculator, so then when you take tests on this, you can use this technology. So when you're graphing down below, just like I had you do yesterday, I want you to graph these, but now with your graphing calculator, and just get a quick sketch and then write some observations to the side. If you want to graph, first thing you need to do is go to your mode, and we need to be in radian mode. And then also, I want you to scroll down to where it says function and then parametric, but go to where it says POR, or POR. Yeah, that L really looks like an R. POL, which is polar mode. If you go to your Y equals, you're now going to see it says R1, R2, R3, R4, R5, R6. What I would like for you to do to graph this first one is, first of all, think how you would graph 3 secant theta. There is no secant button on our calculator, but if you remember, secant is the reciprocal of cosine. So what I can do is I can type in 3 divided by the cosine, and then we can type in theta. Now, theta is where you usually get x, or when we did parametric equations where you got t. Now, if you hit that button, it's going to give you a theta. Before you graph, go to your zoom. The best window to use for these is Zoom Trig. Otherwise, you're going to see the graph gets distorted. Zoom square is sometimes good, but I would go zoom trig because it really sets the window nicely. Now, if you want to graph this and you want to, figure out where to go on this, obviously with this, we could hit trace and you can see that we're 3 units out in X. The problem is it's giving me it's giving me ordered pairs that are in X's and Y's. And I want R's and thetas. Burley, shh. So I can go to second. This dog barks at everything. Like he barks at the wind. He barks at lamps. He has this like arch enemy with one of our lamps that he knocked over before. So if you hear him barking, that's why. So anyway, you're going to hit second and you're going to go to the button that says zoom because above it says format. And you're going to change this to polar GC. If you go back to your graph, he's like spitting up things in the background. If you hit trace, notice now it gives you R's and thetas. So it's telling us that 3 units out at this angle of 0, we have an R value. And notice from here, this is a vertical line. So what I want you to do is play around with this. I want you now to go to your Y equals, change that to a -2 in the front. Insert 2. And then you can go ahead and graph that and see how that changes it. Again, when you go to trace, you'll see that you are getting -2 as an R value with this theta equal to 0. So just keep in mind that you do want to trace, and you can even tell at specific angles too. If you ever hit trace and you wanted to see where you're at, you can always tell it after you hit trace, like a specific angle if you wanted to see, and it would give you that value. So do that, then do the cosecant, and then make the observations on the side. And then go to the back page, and you're basically going to be doing more of this. Notice that if I go to Y equals, I'm now just typing in 3. And when I go to graph, notice that this is a circle as well as the 3 cosine theta, 3 sine theta, but this circle is centered at the origin. Now, when you hit trace, just check to see how far out we go. Notice that this is telling us the radius of our circle. So note that you're going to go out 3 units in each direction. And again, if you hit trace and you tell your calculator to go to pi divided by 2, it'll tell you what the R value is there. And then obviously you'll see that for all of this, it's going to be a circle with a radius equal to that number, centered at 0, 0. So obviously you can kind of play around with your calculator and you can maybe trace this a little bit better than I did. Now, the final ones, I know you can type in the R equal theta, R equal -1/2 theta to see what you're dealing with. But the one that is going to confuse you is this theta equals 3 pi over 4. Because if you go to your Y equals, there is no theta equals. So with these, think about when we are talking about symmetry. And remember I said theta equals 0 is a line. And if you recall, it was your x-axis. If I said theta equals pi over 2, remember that that was a line and it was your y-axis. If I say theta equals, these are always lines. You need to find this angle and think about what happens when your R value is positive versus negative. If I'm at 3 pi over 4, I'm in the middle of the second quadrant. So what I'm going to do is I'm going to go to the middle value and I'm going to draw a line through it. But keep in mind, if I had negative R values, I would go to the opposite side. So you're going to make sure your line extends the entire graph. So that's how you do that. I'll let you figure out that next one, answer the questions on the side. And then for down here, just typing in theta is just as simple as going to your theta button and then going to graph that. And you're going to see that this is what we call a spiral. With spirals, they never have symmetry. You're going to see that if R is equal to theta, for every angle, pi over 6, pi over 4, pi over 3, you're going to see your R value grows with theta. So it's just going to keep getting larger and larger and larger as you move away and choose larger angles for theta. Now, if you hit trace and you want to see what some of these angles equal, you could type in pi divided by 4, and it's going to tell you what your R value is at pi over 4. So if you want to use my little trick with you highlighting the axes, And then if you go to pi over 4, what you can see is that you're approximately at 0.78, so maybe like right here. And then you can just keep typing in other angles. So if you wanted to do, pi over 2, you can type in pi divided by 2 and then see how far away you are, and notice that it's 1.57 because it's whatever that decimal approximation is for pi over 2. So I'm going up 1.57. So what you can do is you can just start creating these points and you'll see your spiral as you're moving away. You can trace pi, and then you're going to see, of course, that's 3.14. Notice that I'm already off the graph, so you can kind of get the idea that from here you're just going to be moving away, and so on and so forth. Finally, at the end of this, I would like for you to do your best to use both of the note sheets to write equations for each of these. Now, if you prefer checking using Desmos or your graphing calculator or a combination of the two, feel free to do what's ever best for you. But one document I would like for you guys to look at is if you go to Schoology. I just want you to note that in Schoology, I have a document that's a great summary sheet. If you go to my page and you go to the 6-5 graphing, there is a sheet at the bottom of the notes that says Polar Graph Summary. If you open this up, this is everything you just learned in these last couple days, where here's a circle, and if it's cosine versus sine, and if that a value is positive versus negative. Lima-Sones, it talks about the difference between them. When do we have an inner loop? Oh, it has to do with the ratio of A to B. When do we have a cardioid? Oh yeah, that's when they're equal. When is it dimpled? When is it convex? Notice convex is like a blob that doesn't go through the pole, but we had talked about why when you use the D value, if you guys remember the midline and your amplitude, you're going to see that you're not going to hit that x-axis. So roses, the petals, the number of petals being dependent on that value that's in front of theta, the length of the petal being that A value, it's all summarized in here. And then the lemniscates, the spiral, and then at the bottom, just the different types of lines. So use this to help yourself as you are trying to create these equations given the graph. It is very challenging, but I know you can do it if you really use the two note sheets and even that